So we have one equation that says negative 2x plus y equals negative 1. And our second equation says y equals negative 4x plus 8. And we want to solve this system of equations. Now, since my second equation clearly says y equals negative 4 plus 8, I think that this is a good example to do by the substitution method. I'm going to do it now by the substitution method. I'll go back and do it with the elimination method to show you that if you really don't like the substitution method, you really can always use the elimination method. You can't always use the substitution method. Sometimes if you try to do the substitution method, you get difficult fractions, but the elimination method always works. But sometimes it's easier to do the substitution because if you take your first equation and wherever you see a y, you replace it with negative 4x plus 8, you get the equation negative 2x plus negative 4x plus 8 equals negative 1. Now, remember, you want to remove this parentheses, and since there's no number in front of it, it's understood as if it's 1. So this really becomes negative 2x. 1 times negative 4x is negative 4x. And 1 times 8 is plus 8 equals negative 1. Combine the like terms. This gives me negative 6x plus 8 equals negative 1. Bring the 8 to the other side. So that we get negative 6x equals negative 9. And divide both sides by the negative 6. And negative 9 divided by negative 6, well, the negative over the negative becomes a positive, and I can divide top and bottom by 3, becomes 3 over 2. So it turns out that 4x, I get 3 over 2. If you wanted to, you could leave it. The best way to leave it is to leave it as 3 over 2. But if you wanted to, you could just change it to decimal form if you prefer that. We're not finished because we have to figure out what the y is. But I'm going to take this equation, y equals negative 4x. I'm going to do negative 4 times 3 over 2 plus 8. Now, I'm going to put this 4 over 1 so I can multiply these two together. If you want, you can take your calculator and do negative 4 times 3 divided by 2. If you do it like this, you're going to get negative 2 and 3. This will give you y equals negative 2 times 3, which is negative 6 plus 8. And when you combine those, you get 2. So your solution is x is 3/2 and your y is 2. And that's doing this using the substitution method. Is there any question about this? Okay. What I'm going to do is I'm going to erase this and redo it using the elimination method. So that'll show you that you really have a choice as to how to handle this. So let's erase this. Go back to this original equation. And I noticed that the first equation, negative 2x plus y equals negative 1, is in the standard form. Negative 2x, the x first, then plus y, equals a number. But the second equation is not in standard form. So if we want to use the elimination method, we need both of them in standard form. So I have to get this negative 4x to the other side of the equation with the next to the y. So I'll add 4x to both equations, and that'll give me 4x plus y equals 8. Okay, that I'm getting from over here. Now I have my equations in standard form set up. I can decide whether I want to eliminate the x or the y. Let's eliminate the x. Okay. This isn't the only way to do it, but you certainly can do it this way. Multiply the top equation by 4. Remember, you multiply them by their alternate, the other coefficient. The first by the coefficient of the second by the coefficient of the first. Now notice, I don't use the minus sign. I just look at the numbers. I multiply the top equation by 4, the bottom equation by 2. That'll make both of these numbers 8. Now I decide if I have to put in a negative sign, but I don't, because this is already one negative and one positive, which is what I want it to turn out to be. So in my top equation, I'm going to get 4 times negative 2x, which is negative 8x. 4 times y is 4y. And 4 times negative 1 is negative 4. My second equation will be 2 times 4x, which is 8x. 2 times y is 2y, equals 2 times 8, which is 16. And when I add these two equations down, the 8x and the negative 8x cancel out. We forced it. We said we wanted to eliminate the x. 4y and 2y is 6y. And negative 4 plus 16 is 12. I'll divide both sides by 6. And that'll give me that y equals 2. Now I have y equals 2. I can go to either one of the equations. Let's go back over here. My y came out to be equal to 2. Let's take the first equation. Negative 2x plus y, well, y we know is 2, equals negative 1. I'll bring the 2 to the other side. So that'll give me negative 2x equals negative 3. And divide both sides by negative 2. And again, a negative divided by a negative is positive, so my x comes out to be 3 over 2. Just like we got before, my answer is 3 over 2 for the x and 2 for the y. Notice it doesn't make a difference if you use the substitution method or the addition method or elimination method, whatever you want to call it. You will get the same answer as long as you're careful with your numbers. You do it whichever way you find you like it better. Okay, so that is pretty much where we left off on Tuesday. And what I'd like to do now is go on to what's called applications of systems of equations. How do we take a word problem that has two different things that you're looking for? How do we set up the system of equations so we can solve the equation and find the solution? And I'm going to do two types now. I gave you some on the Delta math to try. It's the last topic in homework 4. Try them. If you can't do them, don't worry about it, because what I really need you to do, the ones that I really need you to know how to do, are the ones that are on homework sheet 3, numbers 7 through 10. Those are the type you're going to see on my next test, on the midterm, on the final. So this is your homework. You don't have to submit it, but you have to do it. And if you don't know how to do it, you have to bring the questions to me on Tuesday. This is homework for Tuesday. Today is I think that is the 22nd is the date. I'm not sure exactly. I think the date is the 22nd. Okay, so let's erase this. And I'm doing a problem that's from the textbook. So if you have the textbook and you want to see which one it is, it's in section 3.5. I'm doing question number 1. Here's what I'll write the important information on the board, and then we'll work it out. One number is 3 more than twice another. The sum of the two numbers is 18. Okay, they want me to find the two numbers. Find the two numbers. Okay, so we have 2 facts that we know about this. One number is 3 more than twice the other, and the sum of the two numbers is 18. There are 2 things that we're looking for. We're going to need to write a system of equations. We're going to have 2 variables, and with 2 variables, we're going to need 2 equations. So we're going to have to decide what our variables are and write our equations. Okay. What's very important when you're writing a system of equations especially is to write something that's called I forgot what we call it. We have to write down exactly what your variables represent. It's called the legend. Decide what your variables are going to be. Remember, you have 2 facts, you need 2 variables. I'll call my variables X and Y, but you could call them F and S for first and second. You could just use any 2 letters you want. I tend to like to use X and Y's. Now, after I've decided what my variables are going to be, before I start writing the equations, I want to note what these variables represent. And I always base it on what the question is. Now, the question is, what are the 2 numbers? So obviously, let's call X our first number. And let's call Y our second number. That was pretty easy in this case. Sometimes you have to read it more carefully to see what your variables are going to be represented. Okay, once you have your variables, then read your question slowly so that you get each fact separate. One number, let's call it the first number, is 3 more than twice another. So the first number is 3 more than twice the second number, basically. Let's see how we write that. Our first number is x, here's my equal sign, 3 more. Remember when it says 3 more, you're adding 3 at the end. If it would have said 3 less, you would have been subtracting 3 at the end. Remember, even though it says 3 more at the beginning of the sentence, when you write it in the equation, it really goes on the end. 3 more means whatever you have, add 3 to it. Now, what do we have? 3 more than twice the second number. Now, twice is another way of saying 2 times. And the way we say 2 times the second number is 2y. So my first equation that I get from the statement, one number is 3 more than twice another, is x equals 2y plus 3. The next, that gives us our first equation, but we need 2 equations. We need a system of equations because there are 2 variables. The second fact is that the sum of the numbers is 18. Well, when it says sum, it means add. So that must mean that x plus y equals 18. And we have taken this verbal problem, this word problem, and translated it into an algebra problem, into a system of equations. Now, I'm going to give you a couple of minutes to try and solve this by yourselves. While you're doing that, I'm going to call the names of the people who I saw on the participant list who was here. If I don't call your name, it means that I saw you were here. If I don't call your name, it means that I know you're here. Turn the recording back on. Okay, let's work this out now. Again, I see this one as probably easiest to do using the substitution method, because the first equation says x equals 2y plus 3. So it explicitly tells me what x is in terms of y. So in my second equation, wherever I see an x, I'm going to put 2y plus 3. So this is going to be 2y plus 3 plus the y that I had from before, equaling 18. Better look on this side. And combining the like terms, 2y plus y gives me 3y plus 3 equals 18. I'll subtract the 3 from both sides, which will give me 3y equals 15. And I'll divide by 3. So I get that y equals 5. My second number, that was what my y was, turned out to be 5. Okay, remember that I can figure out the first number by replacing the y with 5. So that'll give me x equals 2 times 5 plus 3, which is 10 plus 3, or 13. And now I figured out what my 2 numbers are. My first number is 13. My second number is 5. Notice they do add up to 18. It is indeed the right answer. So that's how we take a word problem, set up the word problem so that we get a system of equations and solve it. Okay, any questions about this? on that third equation. Over here, this 3, okay. Let's try another example, see if it makes it a little easier to understand. Alexandria, are you okay now? Can we go on? Okay, we're going to do another one. Okay. So I'm now erasing this and trying another one. Again, I'm concentrating on the type of questions that you may see on the midterm or on the final, because they stick to certain types, and rather than going into 100 different types of equations and questions, I think if we stick to the type that they have on the final and midterm, we'll be better off. And that's why I said the examples you really have to concentrate on are the ones that are on the homework sheet that I send out, the practice sheet, the practice homework sheet. I think it's sheet number 3, practice sheet number 3 that I posted on Blackboard. Do examples 7 through 10. Now I have posted practice sheet number 4. That's what we're going to be starting to work on today. But right now we're still on practice sheet 3. So listen to this problem. Again, this is still another example from the chapter in the book. Again, it's section 3.5. It happens to be question number 11. And this is what it says. Linda sold 925 tickets for her choir's concert. I'm not writing that out. It's for her concert for a total of $6,000. She sold adult tickets for $8 each, and children's tickets for $6 each. We want to know how many of each type of ticket did she sell. And this is a very common type of scenario. The other one was just a question about numbers. This is a real, what I call a real life situation. Somebody is selling or has 2 types of items, and their values are different. You know what the total of the items are. You know the value of each item. Can you figure out how much of each individual item you have? It could be, as I said, tickets to some game or concert. It could be somebody selling 2 types of shirts. Somebody sells shirts and he knows the price of one shirt is one thing. Sorry. Put this away. Okay, so we're going to do one of these, and I'm going to get you to do one on your own. Again, we have 2 types of items. We're going to write our legend. We have adult tickets. Let's call X. Let that be the number of adult tickets that were sold. I'm not just writing adult. I'm writing the number of adult tickets because I want to be really specific as to what my variable represents. Again, it asks me to find how many adult tickets and how many children's tickets were sold. So my first variable is going to be X. It's how many adult tickets are going to be sold. My second variable is going to be the number of children's tickets sold. So now I know what my variables represent. Let's see if we can write a system of equations using the information that we have here. So the first thing I see is that Linda sold a total of 925 tickets. Doesn't say anything about money there. It's just how many were sold. Well, if she sold 925 tickets, some of them were adult tickets, some of them were children's tickets. The total she sold was 925. So my first equation becomes X plus Y equals 925. I didn't say anything about money here. It has nothing to do with how much. Sorry about this. It's just how many tickets. Didn't matter how much each ticket cost, just how many there were. Now, the second information that they got was that she got a total of $6,000. So now we're incorporating the money. And obviously the price of the ticket is involved here. Let's just think about it. If somebody sells 100 adult tickets and each ticket is $8, the amount of money they're making is 100 times the 8. The number of tickets they have times the price of the ticket. For 100 adult tickets would be $800. So when I'm talking about the $6,000, I have to use not only the amount of tickets, the X and the Y, I also have to use the price. So 8X will be the amount that she's getting from the adult tickets. $8 times the number of tickets, plus 6Y. That's how much she's going to get from the children's tickets, because Y is how many children's tickets there are, and you're multiplying that by 6. Now the 8X plus the 6Y has to be equal to the 6,000. So my first equation just had to do with plain X and Y, how many tickets were sold. The second included the money, the $6,000, so you had to include the price of the tickets. Okay, here are our two equations. It's a system of equations. I'm going to give you time to try and solve this system of equations. Thank you, Kizzy. I think that the best way to solve this is by using the elimination method, because both of these equations are written in standard form. So let's decide, should we get rid of the X's or the Y's? Let's get rid of the Y's today. It doesn't make a difference. If I want to get rid of the Y's, then I'm going to have to multiply the top equation by 6 and the bottom equation by 1. making sure, oh, these are both positive, so I'm going to have to use a negative with one of them. And it doesn't matter if I put the negative with the bottom or the top. If I do that, my top equation becomes 6x plus 6y. Okay, now I have to multiply 6 times 925. I could do that on a piece of paper, but I have a calculator, so I may as well just use my calculator. 6 times 925. Remember, you are entitled to use the calculator. And that gives me 5,550. The bottom equation, I'm just multiplying by -1. So this is negative 8x minus 6y equals negative 6,000. And when I add these two equations down, 6x and negative 8x is negative 2x. 6y and negative 6y cancel out. Well, that's what we were trying to do. We were trying to eliminate our y's. And 5,550 minus 6,000, again, I'm doing this on my calculator, is negative 450. And when I divide by 2 on both sides, I get negative 450 divided by negative 2 is 225. It turns out that the number of adult tickets she sold was 225. Now, how do I figure out what the children's tickets are? Well, let's go over here in this corner. I know from my original equation that x plus y equals 925. So 225, that's my x, plus y has to equal 925. And I'll subtract the 225 from both sides. And I'll get that y equals, well, 925 minus 225 is 700. So I now have my answer. I know that she sold 225 adult tickets and 700 children's tickets. And as I said, this setup, you'll see, they're very similar. Most of the questions that you have are similar. I'm going to give you another one to try now. Does anybody have any questions before I go to another question? Okay, so here's a similar question, different numbers. This is also from the textbook. I have this be question number 12 in the textbook in section 3.5. Jared, okay, let's call him J, is selling tickets to the Ferris wheel at a local carnival. Okay, that's very interesting. It's interesting what his name is. It's interesting what he's doing, but it's not helping me write any equation. It's just giving me the storyline. Okay, so we have this guy, Jared, who's selling tickets to ride on the Ferris wheel. The tickets cost $2 for adult tickets, sorry about this, let me reset up. have $2 for adult tickets. And we have $1.50 for children's tickets. That's what he's selling them for. So again, we have two types of tickets, children's and adults, and they have different prices. The adult tickets are $2. The children's tickets are $1.50. And here's what he did. He sold 300 tickets. He sold a total of 300 tickets to this Ferris wheel. And the amount of money he made was $525. And we want to find out how many children's tickets and how many adult tickets he sold. You want to know how many of each type of tickets were sold. Now, again, I'm going to stop here. I'm going to let you set up this system of equations, and then we'll see if we can solve it. This together. Let's, again, set up our legend and write our equations. Okay, just like before, I'm going to call X the number of adult tickets, because that's what they asked me to find. And Y, let's call that the number of children's tickets. And again, let's set up our system of equations. Okay, the first thing we know is that there are 300 tickets that were sold. Remember, that has nothing to do with how much money it was made. It's just a total number of tickets. So that means that my first equation becomes X plus Y equals 300. The number of adult tickets plus the number of children's tickets is the total number of tickets, which is 300. Now we have to take into consideration the money because of the $525. We know each adult ticket costs $2. So we're going to get 2 times X as the amount of money we're getting from the adult tickets. The children's tickets cost $1.50. So $1.50 times Y is the amount of money they're getting from the children's tickets. And the total is $525. In other words, once I start using the 525, which is money, I have to include the amount of money each of the tickets cost. Now, let's again use the elimination method because we have each of the equations in standard form. Let's get rid of the X's. I think those are the easiest, which means the top equation I'll multiply by 2. And the bottom equation, since there's no number in front of the X, it's understood to be a 1, I'll multiply by 1. And let's use a -2 on the top one. It could have been a -1. I have to have 1 positive, 1 negative, so that I end up, when I add them, eliminating the variables. So multiplying the top equation by -2 will give me -2x minus 2y equals -600. Multiplying the bottom equation by 1 just gives me 2x plus 1.50y equals 525. And I'm going to add these 2 equations together. The -2x and the 2x cancels out. Well, we said we wanted to eliminate the x's. Now I have to add the -2y and the 1.50y. So I'm going to use my calculator. -2 plus 1.50 gives me -0.5. So this is -0.5y. And I'm going to do the other, I like to use my calculator. Even though I can do it in my head, I don't want to make a mistake. So I'm going to do negative 600 plus 525. And that gives me negative 75. And to solve this, I have to divide everything by negative 0.5. Now again, as before, when we have a negative and a negative, it becomes a positive. So I'm going to take 75 and divide it by 0.5. Again, I could do it manually, but it's so much easier to do using the calculator. I get that y equals 150. So the number of children's tickets that were sold is 150. Now we also want to find out how many adult tickets were sold. So let's go back to one of our original equations, and probably the simpler one is x plus y equals 300. I know that x plus, now my y I know is 150, equals 300. So we then get x equals 150 as well. It turns out that the number of adult tickets and the number of children's tickets were exactly the same number. There were 150 adult tickets sold and 150 children's tickets sold. This was a little bit more difficult than the one before, simply because there was decimals, but the concept, the writing of the equations are identical. These are the type of questions you're going to have to do. Again, look at your Blackboard practice sheet 3, questions 7 through 10. They do not have to be submitted, but you have to do them because they're the type of questions you're going to have on a midterm or a final. I'm going to now start chapter 4. Going on to the next chapter, we're going to do the beginning of chapter 4. We're going to be working on chapter 4 for the next couple of lessons. The title to chapter 4 is Exponents and Polynomials. So we're going to be working with polynomials. We're going to remember what a polynomial is. It's what kind of an algebraic expression it is. And then we're going to talk about how we work with these polynomials. How do we add them? How do we subtract them? How do we multiply them? And how do we factor them? That's what this chapter is about. Now, a polynomial is something like this. Let's say I have 3x squared y fourth minus 2xy plus 17 would be an example of a polynomial. It has, in this case, 1, 2, 3 terms. None of these terms are what we call like terms, because in order to be like terms, the letters, the variables, and their exponents have to be identical in each term. This actually has 3 different terms, so it's called a trinomial. Something with just 2 terms is a binomial. And if you have 4 or 5 or 6 terms, then it's just called a generic polynomial. If you have only 1 term, let's say if you have 4a cubed b 7th c to the 11th. This is a single term, even though there are a lot of letters in it. Everything is connected with multiplication. There's no addition, there's no subtraction, there's no division. everything is connected with the operation of multiplication. This is what's called a monomial. Mono means one. Meal, nomial is one number. Remember, the letters represent numbers as well. This is a single term. A monomial is a single term. We're going to start out, we're going to talk about monomials as well as polynomials in this chapter. So what are we going to do? Well, the first thing we're going to do is talk about adding and subtracting of these polynomials. Let's say I gave you a problem like this. Again, if you're looking in the textbook, this is chapter 4. It says, find the sum of x squared minus 6xy plus y squared and 2x squared minus 6xy minus y squared. We actually have two trinomials here. This has 3 terms, this has 3 terms. Find the sum means let's add them. Now when I add trinomials, I just like to put them all in a row. 2x squared minus 6xy plus y squared plus 2x squared minus 6xy minus y squared. Just put it all together on a line. And then I look for like terms. Remember, when you're adding or subtracting, you can only add like terms. What does that like terms means? It means that the literal parts, the variable parts, the parts with the letters have to be identical. They have to have the same letters with the same exponents. The only thing that can be different are what we call the coefficients, the numbers in front. So if I have a x squared, which really means a 1x squared, it's understood to be a 1x squared, and a 2x squared, those are like terms because their letter parts are identical. So I combine them by adding the numbers, the coefficients in front. 1 and 2 gives me 3, so this becomes 3x squared. Then I have a negative 6xy, so I look for another term that has an xy, and there is another negative 6xy. And I can combine them by adding negative 6 plus negative 6, which gives me negative 12xy. Notice the only thing I'm working with are the coefficients, the numbers in front. I don't change the letter parts or their exponents at all. Finally, I have a y squared and a negative y squared. So this is a plus 1 y squared and a negative 1 y squared. That adds up to 0, so I don't have any y squared. My answer comes out to be 3x squared minus 12xy. So we combine all the like terms. It turns out when we added these two trinomials, our answer was a binomial. Let's try another example. I'm going to try another one, then I'm going to give you one to try on your own. Okay, here's what I want you to do. I want you to subtract negative 8x to the 5th minus 4x cubed plus 6 from 9x to the 5th minus 4x cubed minus 6. So I have two polynomials, and I want to subtract one polynomial from the other. Now, first of all, when it says subtract this from this, think about it. If I subtract 5 from 10, you don't do 5 minus 10, you do 10 minus 5. When it says subtract from, what you put first is the 9x fifth minus 4x cubed minus 6. This is the first term, the first expression, and you're subtracting the negative 8x to the 5th minus 4x cubed plus 6 from it. So even though this came first in the when we set it, when we write it algebraically, we have to put this one before this one. This, the word, the expression that's after the from is what comes first. Okay, let's just mention this only has x's, this only has x's. If I look at this, I can tell you what the degree of this polynomial is. This polynomial has a degree 5. It's called a 5th degree or degree 5 polynomial because the largest exponent you're seeing in this expression is 5. It happens to be also in what we call descending order because in this case, the highest exponent is first, then the next highest exponent, then the one doesn't have any exponents. It happens to be a trinomial whose degree is 5 and is in descending order. That's true of the second one as well. Its degree is 5 and it is in descending order. Just want you to be aware of this terminology. When I want to do this work, I find the easiest thing is to remove the parentheses, remembering that if there's nothing in front of the parentheses, it's understood as if there is a 1 there. Now, multiplying the first parentheses by 1 just gives me the 9x to the 5th minus 4x cubed minus 6. This we're multiplying by negative 1. Where there's a negative in front of a parentheses, it means we're multiplying everything by negative 1. So negative 1 times negative 8x to the 5th becomes plus 8x to the 5th. Negative 1 times negative x to the 4th. Negative 4x to the 3rd is positive 4x to the 3rd. And negative 1 times positive 6 is minus 6. And now all we're going to do is look for the like terms. There's a 9x to the 5th, so I can add it to the 8x to the 5th. 9 and 8 gives me 17, so it's 17x to the 5th. Then I have a negative 4x to the 3rd and a positive 4x to the 3rd. So negative 4 plus 4 is 0, it cancels out. And finally, I have a negative 6 and another negative 6. Negative 6 plus negative 6 is minus 12. Remember, this was a negative and a positive, so it canceled out. But two negatives, you combine and add them, and you get negative 12. Your answer came out to 17x to the 5th minus 12. Okay, let's let me give you one to try. Oh, you know what? I think, I don't think I have to give you one to try. I just want to go on to the next topic before we get to the end of class. So let me talk about, most of this I know is review. Let's just talk about a little bit about multiplication. We're going to talk about multiplying monomials, and then we're going to talk about how do we multiply a monomial and a polynomial. So let's say I have these two monomials. Let's say I have negative 3, a fourth, b2, c, times 4, a squared, b third, c fifth. This is one monomial, this is another. When I have them in two separate parentheses and the parentheses are right next to each other without any sign in between, it means that they want me to multiply. And when it comes to multiplication, it is not necessary to have like terms. You only need like terms for when you're adding or subtracting. So how do we multiply? Well, we do it this way. We multiply the coefficients. Negative 3 times 4 will give us negative 12. Then we multiply each of the like letters. Here we have an a fourth, and here we have an a squared. A fourth means we're multiplying a 4 times. A squared means we're multiplying a 2 times. So on the combination of them, we're multiplying a 6 times. In other words, when we're multiplying variables, we have to add their exponents. So it'll be a to the 6th. Now we have a b squared and a b to the 3rd. I again add their exponents, and I get b to the 5th. And finally, I have a c and a c to the 5th. Now, when something does not have an exponent, it means it's understood that its exponent is 1. So this is a 1, and this is the 5, so it becomes c to the 6th. And my answer becomes negative 12, a6, b5, c6. So we don't need common like terms to multiply, only when we add and subtract. But when we multiply, not only do we multiply the numbers in front, we also have to add the exponents, because multiplication of variables or multiplication of things with exponents means add the exponents. Okay, let's see what would happen now if I gave you a situation in which you had to multiply a monomial and a polynomial. So suppose I gave you 2x squared y cubed times 5xy minus 2y squared plus 7x. Suppose I want to multiply a monomial by a polynomial. This polynomial happens to be a trinomial. Well, you all remember how to do that. When you have something on the outside of a parentheses, you have to use the distributive property. You have to multiply the 2x squared y to the 3rd by each one of these terms. So multiplying the 2x squared y cubed times the 5xy will give us 2 times 5, which is 10. X squared times x, remember that's a 2 plus a 1 is x to the 3rd. Y third, or y cubed, times y is a 3 and a 1 is y to the 4th. My first term is 10x cubed y 4th. Then I go and I multiply the second term. 2 times negative 2 is negative 4. There's an x squared here, but no x here, so I just bring across the x squared. Y to the 3rd and y squared give me y to the 5th. And finally, I multiply by the third term. 2 times 7 is 14, positive 14. X squared times x. So it's a 2 plus a 1 is x to the third. And I just bring across the y to the third. And here's my answer. So multiplying a monomial times a polynomial is just a continuation of multiplying two monomials. All you have to do is multiply each of the monomials together. Again, none of these are like terms, so we couldn't combine these. This is my final answer. Now, is there anybody who wants to ask me any questions? How did I get the 10 times 2 to the third? 2x. Okay, here, let's go again. 2 times 5 is 10. X squared times x. Remember, if there's no exponent on a number, on a letter, its exponent is understood to be 1. So I have to add the 2 and the 1. That'll give me x to the third. And for the y's, I have a 3 and a 1, so that gave me y to the fourth. Okay. I'm going to stop right here and just mention